So the next section of 9.2, we're going to talk about the laws of logarithms. And basically what you're doing here is you are using rules to combine two different logs together. Sort of like when you are using your exponent rules, there's certain things that you have to do with the powers in certain situations. And this one, depending on what uh, operation you have, that dictates what you can do with the log's numbers behind them. So we're going to write down the list of log rules that exist, and then we'll take a quick look at an example. So the first one is when you have a log and it has to be the same base. You'll notice that both of these bases are base A. You can only combine if they have the same base. So if two logs are adding together, I know that to combine them, I would multiply their parts together. So if I see the addition sign, I would multiply the x and y piece. Usually those are going to be numbers. Okay, next one. If we have a subtraction sign, once again, same bases. Okay, going from left to right, you would divide the two pieces. So going from the left, x would go on top, y would go on the bottom. So you wouldn't be able to write y divided by x on that one because you're going in the wrong direction. Next one that we have is we have the power. So if I see we have a variable or a number to a power, we'll call it p. There's a rule that says that you can drop the p in the front of the log. So it kind of comes around like that. So p times log a of x. And it turns into a multiplication sign. The last one that's in our log rules is when you have an exponent with a log in the power. Okay, what happens here is that since logs and exponentials are inverses of each other, and if they have the same base, the base here would be a on both the exponential and the log. That leaves you with just this little x out here. So essentially, this part would cancel out with that. Okay, so let's take a look at an example using our rules. So first one, I see an addition sign, so that gives me the green light to multiply their parts. And I'm looking at the base to double check to make sure they're the same base. On this A part, it is both 8s, so I'm going to write log base 8 of 6 times 3, which is log base 8 of 18. And then I'm done. Those two logs have been combined into one single expression. Part B. Log base 5. Both of them have base 5. They are subtracting each other, so that means I get to divide the two pieces. So 9 divided by 3, and then reduce where you can. So log base 5 of 3. Okay. So part C, we have log base 7. And this one here is actually a reduced version of one of our log rules. So if I go back up, basically what happened is this last rule, we had a log base 7 of 7, and that's why they were able to reduce it down to 1, leaving just that x there, or the 1 that we have. So on this little part, this 1 would be log base 7 of 7. And then you can put the little 1 up there if you want to, but that's what ultimately ended up happening, is that you have the log base 7 of 7 and then the 1 at the top, and that's why it was only a 1 left over. So we have 6 divided by 7. Which doesn't reduce any further. So that's kind of the furthest it can go. The last one here, we're going to do it in 2 parts. The first thing I want to go do is go back up to the beginning where my rules are and make a quick note. This one has to go first. It's kind of like PEMDAS, where we have exponents happening first before multiplying and dividing. This third one here would be your exponent rule. And so it needs to go first. So all of your powers will jump back up to an exponent. All right, so going back down to D, we have the same kind of scenario for this 2 here. The 2, same thing as the log base 7 of 7. We need a log base 10 of 10 in order for that to cancel out because it doesn't have a log anymore. And then to be left with just a 2, that would make a 2 exponent on that 10. So let's go ahead and see if we can solve this one out. We have the 2 in the front used to be a power on that 5. So I'm going to change that first. The power is going to go back up to the 5. Okay. And then I'm also going to rewrite the back as log base 10 of 10 squared. Okay. So now all we have to do is go ahead and combine. We have 25 times, because it's a plus sign between 100. Okay. And my final answer will be log base 10 of 2500.